Hello, my name is Ted Hulsey. I'm Vice President of Marketing at eFolder and your host for today's event. Welcome to the eFolder Expert Series. This webinar series brings together experts from eFolder's staff and partner community for deep dive discussions on key service and technical topics. The title for today's session is eFolder Continuity Cloud, a live demo. Today we are joined by Kevin Hoffman, eFolder's CEO and CTO. In just a moment, I will further introduce Kevin. Before we go through the agenda, let's cover a few housekeeping items. Today's session is being recorded. The recorded version of the webinar will be made available on eFolder's YouTube channel. We will also make copies of the slides available to those who attended the event. With over 200 people registered for today's session, we have put all participants in listen-only mode. You can enjoy the audio portion of today's event by either streaming it to your computer or by dialing in over the phone. Questions are strongly encouraged throughout. We have planned a special Q&A section at the end of today's demo, but you may submit as we go along, and we will try to address your questions on the fly. Let me briefly review today's agenda. I will first give a very high-level overview of the eFolder Continuity Cloud and explain the various use cases for eFolder partners. Then I will turn it over to Kevin to give a full-blown demo of the Continuity Cloud and how it works. Now let me introduce today's expert. Kevin Hoffman is CEO and CTO of eFolder. Kevin has served the company in various capacities over the past 7 years. In the past, Kevin has worked as the lead developer for most of eFolder's core technology, software, and service offerings. Kevin assumed the role of CEO 3 years ago. This is Kevin's first appearance on the eFolder Expert Series, and we are thrilled to have him lead the demo of one of eFolder's latest offerings, the eFolder Continuity Cloud. So let me just, thank you, Kevin, welcome. So let's see here. Let's see here. Okay, I'm just getting some background feedback from my colleagues that they couldn't see the slides. So now everybody should be able to see the slides, and this is kind of the most visually important slide to show. So before we go through the demo, let me just give a little bit of context on the eFolder Continuity Cloud. You're all here today. The vast majority of you on the line are likely eFolder partners. And what we wanted to do today is give a hands-on demo of the eFolder Continuity Cloud. The eFolder Continuity Cloud is one of eFolder's latest service offerings that we are on the cusp of releasing. And the eFolder Continuity Cloud is the ability for partners to recover images that have been backed up to the eFolder cloud and actually recover those images in a virtual loss of connectivity like a fiber cut. But in any event, the partners want to be able to have a disaster recovery location that is that will allow them to bring up server images in the cloud and to do so in a very flexible manner on an emergency as needed basis. And the whole purpose of doing that, of course, is you want to be able to get the client's servers or their data back up and operational so that it's seamless to the rest of the client's organization. So their email starts flowing, so they have access to their applications, hosted desktops, whatever the applications may be, you want to make it so that access to those resources is seamless for your clients and that you're able to do so in a very fast manner. And so the eFolder Continuity Cloud supports all of eFolder's cloud data protection services, including the eFolder Aperture Cloud, which is soon to be released. If you're deploying eFolder Shadow Protect BDR, the images that get backed up to the eFolder Storage Cloud from those BDR installations can also be recovered in the eFolder Continuity Cloud. And eFolder Backup, so any file or folder data that you've backed up to the eFolder Cloud can also be restored into the Continuity Cloud. So if we go to the next slide, there's a couple different use cases partners can access, there's a couple of different ways you can build this into your business. The Continuity Cloud gives partners the ability to add a really powerful capability in your own managed service offerings today. So you're able to turn around and commit to your clients that within 24 hours or less, you will have their servers back up and running in the cloud if there's any kind of disaster. So one potential service offering you could bring to market is a premium tier in your managed service offering that includes cloud recovery. And you're able to turn around and extract and charge a much higher premium price point for that sort of service offering. The other thing you could do is you could charge the client on an emergency as-needed basis if you ever need to do an emergency recovery in the cloud. And what business wouldn't pay upwards of $1,000 a week to have one of their servers virtualized in the cloud on demand? So that's another potential way to position a service offering and monetize it with your client base. And then last but not least, the ability to, in a very easy manner, virtualize your clients' servers in the cloud, test them, test the bootability of the server, test the recoverability of the data and the applications. This can become part of your managed service offering where you can actually go through this exercise on a quarterly or annual basis with your clients to prove to them not only that you can recover server images on site on a BDR appliance, but if that site ever goes away for some reason, that you can also do it in the cloud. So again, another way to charge it as an a la carte service, or if you are pursuing a bundle approach, you can include this as a value add inside of a premium priced bundle. So with that, let me turn it over to Kevin, and Kevin will take you through a more technical explanation of the Kevin, why don't I stay on the Continuity Cloud slide here, and then when you are ready to do the demo, I'll give you full control of the demo environment. So why don't we walk through kind of a technical overview of what the Continuity Cloud entails first.
All right, very well. So the idea is that we've got this private storage cloud that eFolder has built up over the years. Engineered for fault tolerance, for reliability, and high performance. And so the idea of the Continuity Cloud is to provide an easy-to-use compute cloud in front of that and attached by high-speed links into our storage cloud to allow you to easily virtualize your customer servers as well as control the networking aspects of your customer through full private virtual firewall. So, essentially the way that it works today is we've got these different physical nodes, machines, with the networking pre-routed and pre-configured to powered by Hyper-V. So partners will be able to log on to any provisioned Hyper-V nodes that's been assigned to them, and then they'll have full access to this private virtual firewall, which is set up, already accepting packets for their public IP addresses assigned to them, and they can, create net routing rules and other, VPN termination endpoints and configure other things to get their customers into that network, the private LAN that any of their virtualized machines are running on. So, those nodes run either Hyper-V for the Aperture Cloud or VirtualBox for the Shadow Protect-based data. So, the concept itself is fairly simple. And then the way that your customers will get access to virtualized resources is through port forwarding, which is of course the simplest mechanism, or you can set up PPTP tunnels, the next easiest mechanism, or IPsec if you want to have the most complex tie into that virtual network. So that's the overview of the Continuity Cloud there.
Okay, so Kevin, I'm going to give you now full presenter control, so you can go ahead and share your demo environment.
Okay, so can everyone see my screen then?
Yeah.
I suppose You can. So good. So the way that this works is when you want access to the Continuity Cloud for emergency purposes, you'd submit a critical ticket into our help desk, and one of our team will provision a node, one or more nodes for you, and you'll get an IP address, a port, and a username and a password. So you can RDP into your Continuity Cloud node. So I've got a node provisioned for me already here with this particular IP address and port. So I'm going to go ahead and log in. And your password would have been in your email. And I'm just going to go ahead and use KeyPass here to log into this. So there's an acceptable use policy. We don't want any hackers on our systems. That's essentially what that says. You're not going to hack other customers using the Continuity Cloud. So this is what the Continuity Cloud looks like. For those of you who use our BDR, you'll notice it's fairly similar in terms of what you see. And that's by design. We're actually using our own BDR. We believe in our own products, so we're using our BDR to power the physical devices behind the Continuity Cloud is the BDR devices that we sell. All right, so the basic outline here is once you're on the Continuity Cloud node, we're going to be demoing the ShadowProtect-based restore and virtualization process today. So what we go through is we decrypt the data, so all of the data stored in the eFolder private storage cloud is encrypted, so we use the regular eFolder file manager tool to decrypt the data. And once that's decrypted and on the Continuity Cloud device, then we use the normal ShadowProtect virtual boot process to quickly virtualize one or more server images and tie those VMs into the internal LAN. We configure the virtual firewall the way that we want to get access to the server, and then we can, from there just access resources like, based on the rules that we set up. So we're going to go ahead and start here with the file manager. So I'm going to log in. You would use your customer's eFolder account, username, and password here, just like you normally would. Choose Restore Data. So I'm going to select here, I've got 3 different server images. I'm going to go ahead and choose to restore all of them. And we're going to put it onto the X drive on this Continuity Cloud node. So notice here, there's about 10.5 terabytes of space on this particular Continuity Cloud node. All right, it's going to ask me to create the directory. So one of the things I'd like to draw your attention to is what we call the 15x restore technology, which is the ability to do parallel restores up to 15 connections at a time. And this can really increase the speed at which you're restoring the data. So today I'm going to choose to use 4 concurrent connections. Pretty much when you're restoring locally across our storage cloud, about 4 connections will get you maximum performance, but 15, you're welcome to use any number that you'd like there. So it's building the list of files it's about to restore and the version information. So all looks fine. So now it's asking for the encryption passphrase here. I'm going to go ahead and type that in. Oops, I must have mistyped that. All right, there we go. So, restore speeds, you can see that it's bursting here, but the average is about 90 megabytes per second. You can expect 80 to 90 megabytes per second restore performance. So, we are decrypting the data live. This is AES 256-bit decryption, and we're almost getting wire speed decryption performance here onto this Continuity Cloud node. So we're restoring, you can see the second progress bar here shows you the global progress. We're restoring about 22 gigabytes in about 4 minutes.
So Kevin, one question that came in from Joel, his question is, if we signed up for the BDR rescue program, would those images also have the ability to use the continuity cloud? And I guess maybe for the benefit of everyone on the line, maybe we should explain what the BDR rescue program is.
Sure. So the BDR rescue program is the ability to take any legacy Shadow Protect powered BDR device, for example, Zenith Infotech BDR devices, that have raw Shadow Protect data on them, and back them up to our storage cloud at a discounted rate to help partners who'd like to migrate to a new BDR platform. You know, and they're just taking those images off the third-party BDR into the eFolder storage cloud. So yes, those images can be virtualized. I believe that the virtual boot process through Shadow Protect does work with older versions of Shadow Protect images. That's been tested before, and if you if you'd like to test that, we can set that up. But I know that's been tested, so that does work equally as well if you're using a Shadow Protect 3.5x version or a 4.x version.
Okay, great.
So while we're waiting on this, I should point out that you can set up multiple accounts at the same time. So I double-clicked on the file manager icon again, and I could log into a separate account here and go ahead and start restoring from yet another account at the same time to the continuity cloud node. So if you had several customers you were trying to get up, you could actually get even faster than 90 megs a second. You might be able to get maybe 95% of wire speed, maybe even 100% if you're lucky, if you were restoring multiple customers all at the same time.
So Kevin, kind of a technical question about what's happening here in the background. Cal asked the question, is the restore data coming from the distributed cloud backups, or is there now a full backup at the eFolder? Or let's see here, the question's moved right as I was reading it. Or there is now a full backup at the eFolder required. So I mean, I think the question is, can maybe explain, from a logical perspective, where were these server images and where are they going from and to, I guess.
Sure. So this is coming from our private storage cloud. The data is coming out of our private storage cloud, which is where your eFolder backups are pushed to. From any of your endpoint devices, they're pushed into our private storage cloud, and then they're coming across our local data center network that we've set up with the 10G backbone-based network to the continuity cloud node, and it's dumping the data to storage local to the continuity cloud node while it's being decrypted. So the data is, it's all the same data center here, going across a gigabit, link through our 10G backbone into this private storage cloud. That's why you're seeing about 90 megabytes a second. That's not going across any WAN, so you should be able to expect good performance.
Okay, another question that came in, Kevin, this is from Michael. Will there be an option in the future for hypervisors other than Hyper-V?
Well, we have VirtualBox here as well, but that runs the Shadow Protect-based ones, and that's what I'm going to be using today. We have considered a VMware-based vCenter environment, especially for larger Aperture installations. Aperture has special integration with the VMware vCenter APIs, and so that's something we may be expanding into. Although at the present time, any of the use cases should be able to be facilitated by Hyper-V or VirtualBox. Aperture can export to Hyper-V just as well as VMware, and all of the Shadow Protect-based backups will go through VirtualBox.
Okay, a different but kind of related question, but John wants to know, what about OEM cloud virtualization? I heard there was a legal issue with OEM.
Yeah, it's a good issue to bring up about Windows activation issues. So the issue is okay, I've got an OEM version of my Windows license that's been activated somewhere on my customer server, and then I want to go and spin that server up in the continuity cloud or even on the BDR device. What happens if that version of Windows is tied to a particular BIOS or something and refuses to virtualize? So that's a planning issue that you should plan for with your customers. We recommend that anyone who's using an OEM version of Windows, you can test virtualize that Windows license on the BDR locally to see if it will virtualize. If that works, then it should also work in the continuity cloud. And if it doesn't work, you would need to upgrade that Windows license to a version that wasn't OEM capable. And that's just part of the planning and sales process for your customers, making sure that they're aware of those restrictions of those versions of Windows. And that being said, the continuity cloud is licensed. eFolder is a Microsoft SPLA license. We're under that program. And so anything running on the continuity cloud, you have full virtualization rights, unlimited Windows virtualization rights, because we're using Windows Data Center 64-bit, which has unlimited virtualization rights. So while you're running in the continuity cloud, at least, you're able to leverage those rights through eFolder for virtualization rights. So, that doesn't mean you still need a version of Windows that's capable of using volume licensing activation. But if you couldn't activate using your own key for whatever reason, eFolder could provide you with a temporary key that you could use while you were running in our continuity cloud.
Okay, great.
All right. So the data was restored here, and it took about 4 minutes and 40 seconds. So it's approximately 5 to 5.5 gigabytes per minute. So if you just take 100 gigabytes, or let's say your average customer is, 250 gigabytes worth of data, then that's about 45 minutes. So it's not instant, but it is fairly quick. And to a business that's got a site-wide outage or a complete disaster, really an hour's time to get them back up and running is not, not that much.
Right. So Kevin, one other question that kind of comes up pretty frequently is, can you talk a little bit about how the continuity cloud can be used for all of a partner's clients? Not just, this is not just a resource that's dedicated to a single client, but this is an environment where they can do restoration of all of their client data, for instance.
Sure, yeah. So you can use this continuity cloud node to set up multiple customers at the same time. You have the ability to set up multiple virtual networks. With the virtual firewall, you can add additional LAN connections into it, so you could have multiple LANs. You're allocated a certain number of public IPs, and then you can divvy those up however you like to, based on this virtual firewall here. Does that sufficiently answer the question, Ted, do you think?
Yeah, definitely, yeah.
All right. Yep. So I'm just going to log out and start over so you're not confused as to what I'm doing. So there's this virtual firewall link on the desktop here. So I'm going to go ahead and double-click that and just log in with the credentials I was given in my welcome email. So it's a pfSense-powered virtual firewall, pre-configured to receive routing packets routed for assigned public IPs. So, basically what you would do here is you'd come in and you configure the internal LAN interface however you like. I've got, a basic /24.100 network here, 192.168.100 set up. That could be anything. Really, you're only restricted from using 172.26. Any other subnet you're able to use here as the LAN interface. So once you've got that set properly, maybe you'll be virtualizing an SBS server which has a DHCP server, or maybe you want the firewall to be your DHCP server. So in my case here, I do want the firewall to be acting as the DHCP server on my LAN. So I've gone ahead and enabled the DHCP server here and given it a range of IPs that I'd like it for it to hand out. And we'll just hit save here. All right. And next, perhaps I'd like to set up some port forwarding rules. And let's just go ahead and edit this rule to see what I'm going to do here. So, I'd like to forward. I'm going to set up a rule that's going to port forward traffic on port 4005 to the RDP port on this internal server I'm going to virtualize. So notice you can have a distinct mapping from different ports on the outside to the inside, and that's useful if you have multiple servers on the inside that you'd want to allow RDP access to or whatever service you're doing without having to use multiple public IPs. So it lets you put more servers on the same public IP. So I've got some public IPs here to choose from. So I'm selecting the one that you see here in parentheses, 38.109.175.129, and then giving it the internal IP address 100.150 on the MSRDP port. And I'm going to save that. So pfSense is similar to Sonic Wall devices in that you create your NAT rules and your firewall rules separately, unlike for example, WatchGuard devices. So it automatically, by default, creates a firewall rule for any NAT rules that you set up. So here we can see that it's already set up a firewall rule for this NAT rule that I set up to allow the traffic inbound. By default, all outbound traffic is allowed, although you can certainly change that here. And then finally, we've got different VPNs that we can use here: PPTP, OpenVPN, and IPsec. So in this case, I've configured a PPTP VPN. So I've got an address block here, 32 addresses starting at 100.192. And another interesting feature is if you had a remote access gateway server that you were virtualizing that was already set up, you could just redirect incoming PPTP connections to that particular inbound host, and that would allow your clients, your customers, to log in using Active Directory credentials that they were already used to using if they already had a VPN set up, PPTP VPN set up. And then here you could specify DNS servers, for example, the IP address of whatever domain controller you were virtualizing if you wanted clients to use an internal DNS. All right. So that's pretty much it. You would just hit save here. And then, if you're using the internal PPTP server, you'd need to set up usernames and passwords. So I've got one set up here already with cc.demo.
So Kevin, a question related to the firewall configuration. Let's hear. So Steve wants to know, can NAT rules, firewall setup, etc., be established ahead of time to streamline recovery?
It could certainly be documented how you would plan doing this. There's really not an easy way to save a particular firewall configuration. And when you are assigned a node in the continuity cloud, you're not guaranteed to have the same sort of DMZ IPs that we assign to you. You're not always going to get the same continuity cloud node. So every continuity cloud node has documented, a different set of public IPs and internal IPs associated with this node. And so, I would recommend just thoroughly documenting and planning out, okay, if I had these public IPs, which ports would I need to forward to which internal addresses? And that's certainly a service you can charge your customer for, I believe, is mapping out exactly what they would need to have access to if they were to be virtualized in our cloud.
Okay, so kind of a related question from Cal. It says, internal IP addresses of the original server/network can be used in the firewall configuration?
Yeah, that's right. So you can use essentially any internal network you want here. The only exception is the Continuity Cloud DMZ is on the 172.26 and 172.28 subnets. And so, if your customers happen to use those two internal subnets, and we chose those because it's quite rare for someone to use those two particular subnets, then you would need to plan to renumber them. But it's very unlikely your customers are using those two subnets, and so as long as they're not, you can use whatever internal networking scheme you'd like to use.
So I think we answered this question earlier, but Cal wants to know, cloud nodes is per client being recovered or per reseller?
So you as an MSP would have access to one or more Continuity Cloud nodes, and you can put multiple customers onto the same Continuity Cloud node. You would come in here and you'd be able to create with VirtualBox up to four internal networks per virtual firewall. And so doing that, you could come in here and create additional LAN interfaces to this virtual firewall. As long as they had different internal subnets, the virtual firewall would be able to route traffic for different customers to the proper interface.
Okay. And then a different question, but also related to the firewall configuration, is there, Todd wants to know, is there any web filtering technology on the cloud to replicate what may have been on site at the client site?
So that we do have outbound filtering on spam to make sure that you're not a spammer and you're not going to poison our outbound IPs by sending a lot of spam. Other than that, we're providing a pure IP-based, basic router and firewall. We recommend that customers would leverage cloud services for their web and email security. For example, eFolder email security in the cloud, so that that would need to be changed if they were going to be virtualizing their customers. And at the present time, all we have is basic firewall and routing services here.
Okay, so Kevin, one more question. There's been a couple questions about Canada, so I think we should tackle them now. So Mike wants to know, our data storage is in the Canadian eFolder data center. Is it possible to virtualize this data in the Continuity Cloud?
So currently the Continuity Cloud is only for U.S. data. As we expand our Canadian presence, that could change in the future. Certainly if we get enough data up there, then we'll put the Continuity Cloud up there as well. You could get access to the Continuity Cloud, but you'd have to go across the WAN between those two data centers, and so it could take significantly longer. Instead of 90 megabytes per second, you're probably looking at more like 10 to 20 megabits per second. Significantly longer to get their data from Canada back into the U.S. So that is a limitation to be aware of right now.
Okay, great.
So we've gone through the basics here of the virtual firewall and router. We've also restored and decrypted some data from the storage cloud onto the Continuity Cloud node. So the next step would be to go through this virtual boot process and to go ahead and virtualize a server here. So let's go ahead and I restored it into live demo. So let's go through here, and you would pick the appropriate point time image that you'd like to use here. And I'll just go ahead and pick something from this morning. This is a relatively new server we've got backing up here. All right, so Shadow Protect automatically recognizes the dependent volumes and the appropriate point time images. So all of this looks appropriate, and we'll go ahead and click Next. And we do need to specify the operating system, so that's another documentation and planning need when you're creating that documentation, is to document the versions of your operating systems. And we'll just give this a name, server name, and we do not want to automatically start the new virtual machine after creating it. Oh, and by the way, we have full directions with screenshots here on the Continuity Cloud node itself. And so, you don't have to remember any of this. This is all fully documented in detail already on the Continuity Cloud. So this particular Continuity Cloud node has 96 gigs of RAM to virtualize with, and 8 cores over two processors. And so we'll just give this particular VM 4 gigs. And we don't actually want to use NAT, although you could, but we want to tie it into the virtual firewall. So for now, we'll just tell it no network adapter. And just warning us that the virtual firewall is still running, and we click yes to have it close the VirtualBox GUI, but the virtual firewall is still running. So we click finish. So if you've never seen this before, the virtual boot process will go through, and it doesn't have to convert any of the data, so the time of this process does not depend on how much data there is. It just exposes that particular Shadow Protect snapshot as a VirtualBox disk. It creates a shim in front of that data, and then it exposes that as a snapshot, and then adjusts the HAL and other drivers needed to go ahead and boot that machine within VirtualBox. The procedure with Aperture is similar. So with Aperture, we're using the virtual standby feature to go ahead and have Aperture create the VM, which is essentially going to be decrypting your data and creating the VM at the same time directly onto the Continuity Cloud node. So the concept is similar. The visual interface that you use to do that looks a little bit different. So this was telling us that the machine was successfully created. So we'll go ahead and start VirtualBox now, and go ahead and edit the settings. And we're just interested in the network settings here. So we're going to enable the network adapter, and we're going to tie this into the bridge adapter, and we're going to bridge it onto this internal LAN network adapter that the virtual firewall is tied to. All right. So now we can, looks like it's waiting on something here. Well, VirtualBox looks like it's having a small problem here, doesn't it? So looks like it's just our luck. All right, well, let's restart this. Yeah, I haven't seen that happen before, so we'll just let this go ahead and restart. And we'll check the settings here. All right. So Windows is just saying, okay, we were running live the last time, obviously because the backups are taken when the system was running. So it looks like the system is just powering on after a power failure or something like that. So it's going to boot up here, and our virtual firewall is already back up.
So while that's going on, so quick question, Neil wants to know, are we going to discuss pricing before ending this as well, before we end the session? And the answer is yes. and we will very briefly touch on pricing and availability. And there was another question, have we fully launched this service to the entire eFolder partner base? And the answer is no. I mean, this is kind of a pre-release briefing, but we are going to be releasing this to general availability to the eFolder partner community soon. So hopefully that answers a couple of those questions that just came in. So.
Okay, well, good. So while Ted was answering those questions, we can see that the server came up here. I went ahead and logged in with the normal credentials. This is server 2008 R2. If this was a domain controller, you'd actually need to start it in directory services recovery mode, if necessary, to reset the IP address. Now that it's using it looks like a different network adapter, because it's a the VirtualBox virtual network adapter. Windows views it as a different new physical adapter here. This server was configured to use DHCP, so it should already have an IP address here. Let's go ahead and check that. So yeah, it's got the IP address 100.151. So we'll go ahead and go back to our natting rules here. And I'll need to edit this rule to make sure that I'm going to 100.151. All right. Apply changes. All right. So now what I should be able to do is I've got the server running, I've got my NAT rule set up, then I should be able to go ahead and connect to this public IP address here, 38.109.175.129 on port 4005 to get into this server. So port forwarding is certainly the easiest way for your customers to get to their with Outlook Web Access. You could forward HTTPS, for example. Okay, and we'll just put in the credentials here through KeyPass. Okay, and this is the same server. I'm connecting through my regular internet connection. Now accessing this virtualized server running in the Continuity Cloud. So another way of getting at the same server is we can set up a PPTP endpoint. So essentially what you do is you go into Windows configuration and we put in the public IP address that was assigned to you, your primary virtual firewall public IP, and we choose PPTP maximum strength, and networking. In my case, I've chosen not to put my default gateway through the remote network, and that's just because I don't want to be disconnected from this demo. But certainly, you could do that. So, for example, traffic would be routing through a default gateway that was in the Continuity Cloud. If you had like an internal firewall server or a proxy that you wanted to enforce security that way, you could certainly have it be set up to enforce the default gateway to go through through that server. And so I'll just go ahead and connect here and show you how that works. So notice this is the username that I set up in the virtual firewall interface. All right, so now I'm on that network, and we can see here that I've been assigned 192.168.100.192 by the virtual firewall, and I should be able to ping 151. So that's the server that we virtualized running in the Continuity Cloud node. And so then, now that I'm on the same virtual network there, I should be able to access resources, for example, going directly to shares or other resources. It does take a few seconds for the Windows SMB protocol to traverse a PPTP network there. But once that comes up, it'll ask for credentials, and then we'll be able to log in there. Okay, here we go. So okay, and this is, just the data that's on that server, and I can browse it just like I can any other Windows share there. So your clients could connect using PPTP from anywhere. Any device supports PPTP, and they could get in. Even mobile phones support PPTP. All right. That's the basic run through here.
So a couple questions came in. So just because I think you just addressed this, but Warren asks, so how would they get to their network shares from their workstations? Wouldn't that change the shares as seen by the workstations? That's what Warren wants to know. So I think you just showed that, but
yeah. So if they had a laptop that was used to being tied into the internal network there through some VPN, those would be all using the same internal IP addresses as they were before. So once they were tied in through PPTP, or even IPsec through some edge firewall device at whatever disaster recovery center they were at, then those IP addresses would be the same, and to them it would all look the same. Their network shares would be mapped onto server names, and that's where internal DNS is important. In my PPTP server configuration back here, it would be important to make sure that my DNS servers were pointing at my virtualized Windows DNS server, so that all the server entries in Active Directory, those would properly resolve to the right internal IP addresses. And so as long as that was set up properly, everything should work properly, including, Outlook and Exchange, anything that they've got using those internal IPs. Once they're on the VLAN, it's just like any other VPN there.
Okay, so Todd wants to know, so realistically, what are we looking at from a time frame perspective from start to finish to configure Firewall and get 3 servers up and running in the cloud?
So to break down the time, you submit a critical ticket into the eFolder help desk, and within 30 minutes we should have to you a provisioned continuity cloud node to meet your needs. From there, you'll need to decrypt your data onto the continuity cloud node device, which we saw was going between about 80 to 90 megabytes per second, or about 5 to 5.5 gigs per hour. And so how long that takes, just depends on how much data you've got to virtualize. You certainly don't have to wait for everything to restore before you start virtualizing. So, I would suggest doing your most critical servers first, your domain controllers, starting multiple file manager jobs to make sure that you've got your most critical servers decrypting first. From there, we saw the virtual boot process took about 5 minutes to go through and virtualize the VM and configure the VM on that network. And then it's just a matter of how complex your network rules are, and how well documented and prepared you are to create the virtual firewall rules. It only takes about 60 seconds per rule, these natting rules here. So it's not complicated, but you do need to be prepared. So, let's say your average server had a couple hundred gigs, 5 gigs per minute, so that's 40 minutes. So you're looking, 1 hour, maybe 2 hours conservatively. 2 hours is probably a better estimate there. If you're building things into an SLA, I would double that, unless your customer really requires something tighter. For customers that do require a much tighter SLA, we would recommend using our Aperture Cloud and then renting, using a dedicated continuity cloud node. So you can pay to use the Continuity Cloud node dedicated to you all the time, for that customer or set of customers, and the Aperture product will actually have those VMs ready to go, and you can pre-configure the firewall and everything, so that literally you could boot up your VM in a matter of seconds on the Continuity Cloud if there was a disaster. And so that, for clients that demand that, very tight SLA that's available, it just, costs you more money, but, you can charge a client for a tight SLA like that 3x or 4x the amount you could charge normally. There's definitely a premium in the market for, near real-time SLAs for customers that demand that.
So, Kevin, a couple questions came in from Raymond and a couple other people. Can you talk about the process of failing back? So if we've had a situation where we had to use the Continuity Cloud to restore client servers, what happens after you've got the location back online or they've got a different location back up and running? So what's the failback process?
Sure. So failback is highly relevant and is important to consider how you plan for that. If you want to fail back, say that you've changed quite a bit of data, and that includes Exchange, you can, if you're using Shadow Protect, you could use Shadow Protect inside those VMs to create new images onto the Continuity Cloud node, and from there, download them to whatever environment you want to use, and then use Shadow Protect to do restores back to the original servers. So there's that method. We can certainly ship you the data, get you set up with a USB device to dump the data to, or a large NAS device, and to be shipped if there's a large amount of data for transit. You can also, if it's only like a file server or a relatively small Exchange server, you could just, shut things down and use a tool like Microsoft SyncToy to actually synchronize the actual change files back. So for very small clients, that might be an easier method. And for Aperture, Aperture 5 has some really interesting features where failover and failback has been made into a much easier process. And so while an Aperture VM is running, an Aperture 5 VM is running in the Continuity Cloud, it can actually back up to the Aperture core running in the eFolder Aperture Cloud, and then there's a mechanism already for failing back and replicating only those changed recovery points back down to whatever site you originally were using. And so there's some some new logic coming with Aperture 5 that will make failback even easier for those clients on the eFolder Aperture Cloud.
Okay, can you talk about how the pricing works? So I've toggled the presentation back into the PowerPoint, and I'm now showing everybody the Continuity Cloud pricing, which I'm sure you see as well. Can you talk about the pricing, and how does a partner spec either a medium or a large Continuity Cloud node?
For sure. So, we've priced this to be very reasonable. And in fact, if you compare this to Amazon pricing for similar resources, you can see that we're more than 3x less expensive than you would get for similar server resources in the Amazon or Rackspace or other similar clouds like that. So essentially, the way that we've priced this out is it's a a la carte, you pay for what you use model wholesale. So, Ted, perhaps you could explain for us, just give us a brief overview since you're so good at it.
Well, yeah. So, so from a pricing perspective, the first thing I want to note, because a couple questions came in just related to Aperture. So, the eFolder Continuity Cloud can be utilized whether you're using the eFolder Shadow Protect BDR, or you're using eFolder Aperture Cloud Services, or you're using eFolder File and Folder Backup. So any one of these data protection services you can utilize the Continuity Cloud to restore either the data or the images. Okay, so that's the first point. Second point is that the way we've really tried to distinguish the eFolder Continuity Cloud pricing is we don't charge you anything if you'd ever use the resource. So it's a really flexible compute resource. So you are only charged on an emergency or as-needed basis only when you request the resource. Now, the pricing is $150 a week, minimum 2 weeks for the medium node, and for the large node, it's $450 a week, minimum 2 weeks. So very simply, if you had a medium node and you wanted it up for 3 weeks, or you had it up for 3 weeks, you would be charged by eFolder $450 wholesale to you, the partner. And when you have that resource up for 3 weeks, you can do test restores for a single client or for 10 clients, or you can do an emergency restoration for a single client or 10 clients. It doesn't matter. So this is the wholesale pricing to you, the partner, the eFolder partner, and it really allows you have a very fixed and definable wholesale pricing, and it allows you a lot of flexibility on whether you take this cost and mark it up to your clients, or whether you just factor it in as a wholesale cost of doing business. But that's how the pricing works. And I think if you compare it to other resources in the marketplace today, it doesn't require you to make a big upfront storage commitment to eFolder. You're not paying for it every day of the year, even though you're not using it. If you have deployed a single eFolder Shadow Protect BDR, or if you've deployed a single eFolder Aperture Cloud location, you can leverage this resource because your images are backed up to the eFolder Cloud. So, Kevin, why don't you?
The question is going to be asked, what resources do you get with the medium and large nodes? So the medium node is 32 gigs of RAM and about 3.5 terabytes of disk space. The large node is 96 gigs of RAM and about 10.5 terabytes of disk space for you to work with.
Okay. Let's see here. So let me just try to tackle, let me just try to grab a couple other questions. So Kevin, just a quick question about DNS. This is a technical question. How do you handle DNS? So back when you were, I think, showing the accessing the file or the Windows file directories, the question from Todd is, how do you handle DNS since it usually takes up to 24 to 72 hours for propagation? So can you talk a little bit about DNS propagation?
Sure. So that's a really good point. We recommend setting short TTLs, time to live, on your key customer services, so that if you do need to redirect them, for these public host names that you've got, for example, MX records, if you're not using some sort of cloud front end for your email service, then I would definitely recommend choosing a short TTL, something like 60 minutes or shorter if your client has needs to redirect more quickly. But typically I would recommend 60 minutes. That way, you'll be assigned the public IPs when you're given the Continuity Cloud node. And so the first thing you would do is you would go change those DNS records, and then you would start the decryption process on the Continuity Cloud node. And by the time that changed, any cached DNS entries would be expired, because the time to live would have told caches, don't cache this information for more than 60 minutes. And we've found that to be a reliable method of switching your public services and host names like web servers and other things over. For customers that demand responses more quickly than 60 minutes, we would say that there are other services available. For example, the eFolder email security product, which would give you the ability, the cloud-facing IP address wouldn't change, and then you would be given the controls internally to redirect that service more quickly. So, for example, with the eFolder email security product, you would just, you can instantly change the internal routing rules of your mail, and your mail would still be first hitting the eFolder email security cloud. So
Okay, so one last question. I think Cal and Joel both asked questions about pricing, just in terms of using this as a resource to test the recoverability of images for your clients. So Joel wants to know, so if we wanted to test the images every quarter, we could use 2 weeks for $300 and schedule testing for all of our clients every quarter? And the answer to that is yes. That's exactly how you would get predictability in your pricing and how you would kind of schedule in these wholesale costs for you to have a really robust testing regimen in place every quarter, where you could then, in that 2-week window, test all of your clients in that compute node. So we're kind of a big fan of starting on time and ending on time. So with that, let's make that the last question. Kevin, thank you very much for a very informative demo today. And for all of the eFolder partners, if you have additional follow-on questions, we had a ton of questions here. We didn't get to all of them. But if you have additional questions, I encourage you to work with your eFolder account manager to get any additional questions you have answered. And thank you very much for joining us for today's session. We will be sending out copies of the slides and a link to the recorded version of this session if you want to share it with a friend or colleague. So thank you very much, and have a good day, everybody. Bye-bye now.